Hello and welcome to another session in physics. In this session, we'll be looking at the topic projectiles and falling bodies. But before that, let us review the previous lesson. Welcome back. At this point, let's see what we mean when we talk about projectiles. A projectile, you see, is an object or a body that is launched into the air and is allowed to move on its own or move freely under gravity. A projectile motion, put simply, is one that follows a curved or parabolic path. What do we mean by curved or parabolic path? Think of something like this. Something like this. This is a parabola. It's more like a semicircle, but not an exact. It is not a straight line, but more like a curve. So that's a projectile motion, a parabolic path. This is because of two independent motions that are acting at right angles to each other. So basically, it's more like where the vertical comes together. The horizontal comes in contact with the vertical, and then they more like form a path that looks like this. So these motions, like you can see from the slide here, are horizontal constant velocity and vertical free fall velocity. On the next slide, that is exactly what we're talking about. For instance, let's say a football is being played, kicked up from the ground. You would notice that the ball does not exactly go vertically, nor does it go exactly horizontally. It is more a combination of both the horizontal motion and the vertical motion. It's a little bit of both of them, which results in a curved path. Now, projectile is a two-dimensional motion of an object that has been thrown obliquely into the air. When we talk about obliquely, we simply mean randomly, haphazardly, carelessly into the air. So the path that has been followed by a projectile is called a trajectory. The path that has been followed by a projectile is called a trajectory. So think about a basketball that has been thrown up. Now this basketball follows a path we call a trajectory. Examples are when you throw a rubber wall and it rebounds from the wall, and you have an athlete doing a high jump. His motion, when he jumps from point A to point B, his motion is more like this. And then you have a stone fired from a catapult. A stone fired from a catapult most likely is going to go like this, so that's a parabola as well. A bullet fired from a gun also has the parabolic motion. And then we have a cricket ball thrown against the vertical wall. None of these things happen straight. Or you see from the diagram here an archer shooting a target. The path of the arrow is a parabolic one. It doesn't go in exact straight motion due to the horizontal and vertical motions meeting with each other. So at this point, the horizontal and vertical components of a force are given as, let's say, the vertical component Ux is given by U sine theta. This one is the vertical component. And then we have the horizontal component. Sorry, please, this should be Uy. Then we have Ux, which is the horizontal component. The Ux, which is the horizontal component, is going to become U cos theta. Because most times, normally, 100% of the time, X is used for the horizontal axis and Y is used for the vertical axis. So, horizontal component. And this is how it is written. Now let's see the formulas for determining time of flight, range, and maximum height. Time of flight, range, and maximum flight. So the formula for determining the time, T, time of flight, T. It is given by T equal to 2U sine theta all over G, where G is acceleration due to gravity. And then we have range. Talking about range, R. talking about range. Range is going to be given by equal to u squared sine 2 theta all over g. That is for the range. And then when we are talking about the maximum height, which is which? Maximum height is given by u squared sine squared theta all over 2g. So these are the formulas that we use. But sometimes too, when we have like our maximum range, our max is given by u squared over g as well. So at any point in time, use any of these formulas to find the time, the range, maximum height, and maximum range as well. Now let's look at the applications of projectiles. Applications of projectiles are uncountable. They are so numerous. For instance, they are used to launch missiles in modern warfare. You see a rocket here, then you see bomber tanks used in warfare. It is also used to give athletes maximum takeoff speed at sports. For example, in track sports, it is used to project them and give them maximum takeoff. Those that are running 100 meters, 200 meters race. It is also used in those who are doing pole vault to give them maximum takeoff. You can have those doing long jump as well, gives them maximum takeoff. Alright, at this point, let's take this example. This example says that a stone is shot out from a catapult with an initial velocity of 30 meters at an elevation of 60 degrees. And we're asked to find the time of the flight, the maximum height that has been attained, and the range that was covered by the projectile. So let's start by finding, first of all, the time of the flight. Time of the flight, t, and it's given by the formula 2u sine theta over g. So we continue, 2u sine theta over g, where t is equal to, we have 2 here, first of all, multiplied by our initial velocity, which is u, is 30 times sine, the angle there is 60, sine 60, all over 10, which is acceleration due to gravity. So when you do all this together and taking into consideration that you have to find the sine of 60 using your calculator, you're going to get 5.2 seconds. That's the answer to that. The maximum height attained, or you can call it the maximum height reached. So this maximum height is going to be given by u squared sine squared theta over 2g. Alright, so let's continue from this article. So we have our u squared, which is 30. So h is equal to 30 squared. 30 is our initial velocity, and we're going to use it to multiply sine squared 60 in bracket. 2g means 2 times 10, which will give you 20. So this will become 30 squared times sine squared 60 close bracket over 20. So like I said, it's going to give you 33.75 meters. At this point, let's talk about the range. The range is r. The range r is given by the equation u squared sine 2 theta all over g. So our range is going to become 30 squared sine 2 times 60 all over 10, which is going to give us 30 squared sine 120 over 10. If you run your calculations very well, you're going to have 90, since 900 rather, 30 squared is 900, sine 120 all over 10. Our range is going to become 77.9 meters. This is 77.9 meters. And that is the solution to this question. Thank you for joining us in this lesson. To refresh your memory on what we've just discussed, please take the test that will appear on your screen.